I'm Mark Stosberg. I work at Somersault. I'm on Perl-driven websites. I've been working on the same project for 10 years, and we started with the test suite, and it's continually grown. We're up to the point now where we run about 20,000 tests every time we push a commit, and that now takes about 5 minutes. It used to take as long as 30 minutes, and I'll be talking today about how you might be able to make similar gains in your own test suites. To get started, I want to get a lay of the land of how it is for you. How many people have a test that takes more than 5 minutes to run? More than 10? More than 30? More than an hour? Okay, so some of you have that kind of benefit. About how many tests are there? More than 1,000 tests? More than 10,000? 50,000? Quite a lot of tests. Sometimes it's sort of arbitrary how many tests those are. So we'll be speeding up your test in a number of ways. I'll be talking about running your test in parallel, speeding up browser-based tests, speeding up your unit test, finding your slow test, and other test process speed-ups. The absolute number one thing is running your test in parallel. How many are already running tests in parallel? Just a few. So this is a big deal. Most machines have multiple cores in them now, and if you're running not in parallel, you're probably taking advantage of just one core perhaps, and you really can get an improvement that's a measure of change of running 4x parallel can get you close to 4 times faster. I said our project is a database-backed website. We have over 50 tables and a lot of fixture data, and because of the time it would take just to set up a basic database, it's not feasible for us to take every test file and have that run against a fresh database so that they can all be isolated from the others in that way and still get decent performance. So our techniques are built on the premise that there's other tests potentially modifying the same database. And if you can write tests in the face of this, and you can get that extra performance benefit of not doing this whole setup and teardown every time you run a test file, since the test files can potentially take just a second or so to run if they're small, or longer if they're large. Here's some basics of parallelizing your test. The prove tool, which is already out there and popular, it already has a J option, and you can specify the number, how many ways parallel you want it, and a good starting point is your number of cores, but keep checking up and down based on that and find out what the fastest is on your system. It might vary a little bit, and I put the syntax up for putting default in your .proverc file, and you can just that way you can run in parallel by default, and we do that even if we do this for what we call the smoke bot, which is just our test suite run, but we also do it by default for developers. And then if you want to test just in serial, you can add -J1 to override that and do just a single run at a time. The prove tool has had for several years a mechanism to actually specify a mix of, they call it rules, to specify some tests running in parallel and some tests running in serial, but it went undocumented until just in the last few months I found it, researched it, documented it, and that documentation has only recently been published. And so now if you go to the prove docs, you'll find this rule system for specifying a mix of serial and parallel tests. So then I tried to go further and implement that, but I ran into bugs and complications with it, and it actually turned out for me to be fast. It was faster for me to just get my tests to run and be parallel safe than it was to keep trying to support the non-parallel tests. So I'm not actually taking advantage of that now, and I would advise you also, based on my own experience, to just spend some time trying to make your not parallel tests parallel safe, and instead of trying to avoid it. I'll get into more about how to do that. First, we'll talk about how to find your tests which are not parallel safe. It's a fairly straightforward process. You start by getting all your tests to pass on a serial run, and then you run all your tests in parallel, and then you notice what fails. So it's about that's how it works. But if there's randomization in your test suite and the orders are different, the timings are different, you need to really do the last step several times, because it'll take several runs for two things which might conflict to trigger a race condition or something. But that process does eventually work itself out. This is a really basic technique, the basic technique that we use for creating our tests that can safely collaborate with each other. When I say entity, I'm thinking in the database sense. It's basically insert an entity into the database, usually through the back door, because that's fastest. Just direct database insert, do whatever you're testing with it, because you inserted it, you know the ID, and then you can throw it away when you're done. And that covers a lot of cases, and it's simple to do. It's a web-based project, and sometimes our testing is stuffing web forms, testing good input and lots of bad input, and we don't get to know the ID of the thing that's going to be generated in advance. But that's a fairly easy recipe for that. You're probably using Mechanize for your web-based test. You can just generate a random value, like if it's a first name field, you can put a first name field in, and then you can find the exact value that you're working with after the fact. Your test suite can make a select on the database and look up something with a random and unique data, and now you're sort of back to that case where you know you're uniquely working with a field that you just inserted. A variation of that which didn't work, which I should mention, is we used to say, after I insert, I'll just select the ID of the last thing I inserted. MySQL, they call it last insert ID. You can't do that because something else will run right at the same time, and you'll get an off by one problem. But if you insert a unique value and then select that, then that's has a good chance of working. This next technique was sort of something I figured out which helped quite a lot. And so if you have something like a search and you're running a search in one part of the database and another test might be searching the same part of the database, the generic idea of just inserting entity, working with that, and cleaning it up, it won't work. You need more isolation than that. And instead of starting with a whole new database, what we found worked really well is what I call a temporary masking table. And it's just it's a temporary table, but at least in Postgres, you can create a temporary table which has exactly the same name as the target table. So what it is, it's a private copy and view of the table just for your session that nobody else can see. So you can even have two tests doing the same thing in parallel, and they'll each get their private copy of the table with the same name.
I'm sorry, you said that's Postgres that did that?
Right, yeah. I didn't research all the other databases, but you could apply the ideas, and I'm sure something similar could work.
So that it's private to the session, so that when you kill the session, it goes away?
Absolutely, and automatically. You don't even have to drop it, yes. Yeah. Now, a lot of this depends on the next trick, because, so I'll go into some more, but for this to work, your application has to share the same database handle as the test suite, otherwise it won't be seeing the same view of the table. And so you get two speedups from this, or you get the parallel safe speedup, but also your temporary table that you use to mask the actual table can be empty or minimally sized. It can be whatever you want. So if the old slow test used to run on 10,000 rows, you can now run on 0 rows, 10 rows, however many you want. And I'm going to go into more detail on these points. And yeah, as I said, works at least with Postgres. There's temporary views too. Same idea. This is the sort of the first version I took. It's really just create the temporary table with the same name as the other one, select star limit 1. But before you take notes on that, this is the better way to do it. in Postgres, you can say create temporary table with the same name, like the other table, and including all. And what including all means is that it includes all the same defaults, all the same constraints, all the same indexes, all the same storage options, and even all the same comments on it. So it is extremely like the table it's masking, but it just takes a really small amount of time to set up. So you get this temporary table, it's just like your main table, and you're all set to go with it. And that's the one I use. The first variation, maybe, I don't know, maybe you'd use that if you wanted 10 rows of random data to start with or something from the other table. But so if you have a unit test, it's the simplest case. You create the table at the top of your test script. You make sure you share the same database handle, which I'll show in more detail. And then you just run your test as normal. So it's an easy retrofit if you're writing tests. We had to retrofit because we did this thing where we weren't running in parallel, and then we had to figure out how to fix things. And this worked. It doesn't have to be hard to share the database handle if you're already getting your app object and your app object has an easily accessible database handle in your test. You can just use it in your test. It doesn't have to be complicated. I'm sure maybe there's some reason it could go wrong, but pragmatically it has worked for us. Again, just another example, it doesn't have to be complicated. It doesn't matter which way you assign which to the other, just as long as they end up being the same. So this capital DBH is just the idea of something that's in your test suite. However you want to do it, just assign them to each other and go from there. Now, sharing a database handle with mechanized tests got to be interesting because I like this technique so much I wanted to apply it to more than unit test. So I thought, how can I apply it to mechanized test? So there's a problem. To do this, your app and the test and the app have to run in the same process. I'm like, well, I can't do that with Apache because my test suite is in this process, and my Apache ModPerl application is in this process, and they can't share the database handle. So I thought, how can I solve that? So I looked at the guts of these testing modules that are available on CPAN. There's TestW Mechanize, there's Catalyst, there's CGI app, there's I'm focusing here on PSGI, but the ones I've looked at are implemented the same way. It's actually the same process. It's testing on the front end, and then test at some point passes it off to the application in a Perl sense, and it gets done, returns, and passes it back, but it's all the same process. So by using this for some tests instead of the Apache ModPerl usual Mechanize, then you can share the database handle because same process. But it's still a little bit tricky. This is a closure technique. I'm not necessarily, this is just an example. You can figure out another way to do it. If your database handle was available in a class, or like a class method, they could share it. They could both access the same class method, or in this case, it's the idea that my PSGI app actually has a little wrapper where within the wrapper it accesses a database handle from the test suite, so they set to each other. There's different ways that you could solve it, but the key thing I'm sharing is the idea that you can do this because with these kinds of tools, they are in the same process. You could also decide that, well, I could make that a unit test too. But the main thing there is just the idea. Implementation details are up to you. I'm going to move on to some improvements I found for browser-based tests, both with Mechanize and Selenium. And when I talk about Mechanize, I'm talking, for me, it's test www Mechanize. And with Selenium, I'm using the Selenium remote driver Perl module, and it has a similar testing related class called test WebDriver. And okay, let's see. Oh yes. So first one is only use Selenium if there's JavaScript involved because it's slow. When you're using Mechanize, you're driving a browser directly. You say get a website and it gets a website. When you're using Selenium, it's already sort of inherently slow because it's driving a real web browser. But the whole model is when you say tell Selenium get a web page, it's sending an HTTP request to the Selenium browser, which is then sending an HTTP request to the server. So there's an extra layer of abstraction. These extra HTTP requests are generally slow relative to just anything on the local file system. So our rule is we use Mechanize wherever we can and Selenium where we have to. Let's see. Phantom.js has come up in some slides and some presentations already, and I recommend it. Selenium normally drives real web browsers, like desktop web browsers, Firefox, Internet Explorer, and that's, I mentioned, somewhat slow. Phantom.js speeds this somewhat up because it's a headless WebKit browser. So if I'm running my test on a server, this headless WebKit browser can be right there in the server, and that speeds up the interactions versus more network connections and so forth. And Phantom.js can work, has the same interface as a Selenium server through something it calls the Ghost Driver extension. So you can, your tests can be unmodified and run first against Phantom.js and also against another Selenium server. And yeah, it's significantly faster. We're just now getting into this, but the planned design is that our fast Phantom.js tests we're going to run on every push, and we'll run on all supported browsers on a nightly cron job, and that's another way to keep the common case fast, but still get all the quality we need from testing all the browsers. This is a pattern which I just recently fixed in my code. If you're using Mechanize tests, this might look familiar. You've got a form, you want to test a good input and some bad inputs, so you load the page, you submit some bad inputs, you check for a result, you load the page, you check for more bad inputs, you load the page, you check for some good inputs, you check the page. Well, that has all these HTTP requests, but this get OK that happens 3 times, you're just doing all this work and getting the same answer all 3 times if you know the form isn't changing. So that can be sped up. And one way to do this is to get the browser in the state you want. By go ahead and creating your Mechanize object, you go ahead and get the page, but then instead of refetching the page, you just reclone the browser that was already in the state you wanted, and then you eliminate all those extra HTTP requests. I just worked on a test where we had retested the form like 10 times, and I was able to cut out like 9 of those extra requests because we just were cloning the browser at this initialized state instead. This is a variation on the same idea. If you're testing a form with Mechanize a bunch of times, you can submit the form once through submit form OK, and that makes sure that the form has all the fields you want and that it can generally submit OK. But after that, you can skip reloading the page again and just potentially post to the run mode that processes it over and over. This is, I think, a weaker test than the one I just showed you, because you could accidentally submit a post request which was invalid in the sense that it wouldn't submit through the form. But if you were writing a web services for API testing, some other cases, I just thought it would be worth showing as another way to do things. Yeah. So as I wrote on the slide, if you have a lengthy way to do things in a shortcut, take the long way once and the shortcut the rest of the time, and I'll show you a particular way that I use this idea to speed up logins with Mechanize and Selenium. So a common thing for us is for certain features you have to be authenticated with the application. You have to have a user. The user has to go to the form and log in and then get to their home page, and then you can finally test the feature as this authenticated user. And we put that in a function, and it has to follow this basic recipe. You insert the user, you get the login page, you put in a username and password, and you submit. And that submit actually sends them to our home page, which makes an extra redirect. So there's actually 3 HTTP requests here: the initial form load, submitting the form, and then getting redirected to your home page. Anyone else writing code like this for testing websites? Yeah. We had a lot of it, and then it used to be worse because it wasn't encapsulated as function. It was all sort of copy-pasted in test. Here's how we fixed that. I said, okay, well, look, we'll test the login system in one place, right? And we know that works. We don't need to redo that everywhere else. So the fix is We still insert a test user. We use a backdoor function. It says just set the user logged in. For us, that's inserting a row in a session table and getting back a session ID. It's probably similar in other web apps. The ultimate result of logging them in is they get a cookie set in your browser. There's a fairly new module, HTTP cookie jar LWP, and it allows you with a nice little add method to add a cookie, and then we just initialize our Mechanize with the cookie it needs to log in. So for all these cases, we went from 3 HTTP requests for this login setup to 0. And that was a win. But our code coverage is no worse because we cover the login system still in one place somewhere else. I was quite excited to see what would happen to apply that to the Selenium logins, which we also do. And as I've just told you, the Selenium model is that you first send HTTP requests to the driven browser for Selenium, and then it sends the HTTP request off to the internet. And some of the methods that you see on the slides here are actually shortcuts, so they do more than one thing. And so this same flow in Selenium, it actually takes 12 HTTP requests between the one that you send to the browser and the ones it's making off to the internet. And then we're doing that again all the time. You log someone in. So you can apply the same pattern to a Selenium login. It already has an add cookie method right there in Selenium. You still, because it is a real browser, you have to visit a page before you can set a cookie. So I arbitrarily visited the login page, but once I visit the login page, I can skip all the other steps and just set the cookie in the browser. So it's still a little more overhead because of the model, so I couldn't get down to 0, but I got down to 3 HTTP requests from 12 from this common case. So that was speeding up a really common pattern. Again, just knowing that this whole model with Selenium is different, what appears to be local, like you're used to with Mechanize, is not really local with Selenium. So another pattern we have is we load up a page and we test the content for one regex, we test it for another, test it for another, test it for a DOM element. What I realized was happening with Selenium is when we were applying the same approach, it was making all these HTTP, it was asking the browser, what's your page source so I can check it? What's your page source so I can check it? What's your page source so I can check it? So once I realized that, then I realized we could refactor it. So you say get the page source from Selenium once, and then you just check regular expressions against it multiple times, since you know it's not changing. If for some reason the content might change, you would need to refetch it. The Selenium remote driver is a fairly young project because the Selenium API has changed. So an improvement like this could become built into Perl's interface to the Selenium tools, but right now it's not there. This is just a fancier example of the same thing. If you want to use, instead of just regexes over your page, if you wanted to do DOM checking, you could load the page source once from Selenium, turn it into a Mojo DOM object, and then you could do fancier checks against the page. And Selenium has a way to do that, but then again, you're hitting the browser every time and adding all these network requests to your test. How many of you have heard of Sauce Labs? Oh, great. So we'll whip through these. It's a Selenium-based testing service hosted at Amazon. They allow you to run your test on a combination of over 150 operating systems and browsers, and that includes newer browsers, mobile on iOS and Android. So when we talk about running our Phantom.js tests, most of the time in our other tests, our supported browsers overnight, we're using Sauce Labs. It also has its own parallel testing system that allows you to run tests there in parallel. I'm going to talk some more about speeding up unit tests. ForkProve is a fairly new project too. I call it ModPerl for test. The benefit that it brings from ModPerl is ModPerl has a startup file, allows you to preload a bunch of things, and then when it gets forked, you already have all these things preloaded in your module, preloaded in your process. And ForkProve has the same design. allows you to specify a preload file where you preloaded a lot of things, and it would fork and run all your tests. And yeah, we actually made a project preload.pm, and we tested it with both ModPerl and forkproof. So if you're already doing one, you don't have a lot of setup to get ready to do the other. Yeah, if you're loading a lot of Moose every time or other heavy modules every time you load a test, this could be something to look into. But it may not just work. Some things are not ready and expecting to be work in this model, but and it didn't work for us. I don't remember exactly what it was. It might have been CGI PM or something else. Hey, but it's really cheap to try. Just as I said, just try it, and it's cheap to see what breaks, and you'll have a sense of how hard it might be to get it to work. When I tried it, I did find it was going to benchmark better if it wasn't for the failures that there. So we didn't end up using it, but it's worth a try for you. Just classic, same coding principles apply to test. One that worked for us was just clearly naming and organizing the test. It helped us find duplication. Let's see what my next slide is there. Yeah. So we said, okay, our unit tests were all just named with no particular structure. We started to name them exactly after the module name, and then within the module, every test method where you're using a test class style was named after the method. And when we did this, some of these ad hoc naming things, when we moved them into this structure, we found that duplication, because once we put the standardized structure in, we found two tests were suddenly right next to each other, which were for a part. And then once we saw them right next to each other, we could delete some of them. And that's an easy way to speed up your test suite, is delete duplicate code that you didn't need to be maintained anyway. So if you don't have, especially, so partly what we're talking about is managing a larger test suite, and as your test suite grows, formality helps you manage the growth.
Could you explain method to test description? Is that?
Oh yeah. So if I was testing if in my class I had a method named Spring, then when I was testing it, I would name my test class method Springs well, or I would just start with the method name of the thing I was testing, so that.
You're just suggesting using a long method name that describes what the test is about.
Right, and there's this. Depending on your testing system, test class Moose has you start with a test prefix. Other testing systems allow you to put nice strings instead of trying to put a big name into a subroutine name. I actually would like to use that style eventually. But any kind of consistency will help you. This is something I fixed in a number of our tests. Was test class style systems allow you to do per test file setup. So you do something once for each test file you're running, or once for each test block. And we had a lot of tests which were doing per test block setup, but it was like fixture stuff that never really changed. So we were inserting and deleting a lot of stuff in the same test file that was never modified. It was the same between all the different test blocks. And I found that I could, in a lot of cases, just instead of doing it per every test block, I could do it once per test file, and that was a speed up too. So look for those cases where if you may be sort of over isolating, you might be able to back up a little bit. This is something I created a slide, and then since I created it, I'm not sure it's a good idea. We were using Moose, and I thought, oh, Moose is heavy, right? If I can just create a few things, I'll switch them to Moo. We won't spend so much time loading Moose in our unit test. But you have what I call the Moose tipping point, where once you're loading it once for anything at all, you've loaded it, right? And you might as well have it. And we actually had that. We had some things which just didn't have Moo equivalents, but you might start with Moo in a new project and upgrade when you need it, but the more I thought about it, the more in any large project, you're probably going to end up needing Moose for something anyway. Our project uses Amazon's S3 service, so we use net Amazon S3, and it's based on Moose. There's no other, it's not a good alternative. So I guess it's something to consider, but it didn't end up, there's a good chance it won't work out. Another marginal tip that might be more of a code smell than something to fix. We had a base class which was used all the time, and it was loading this S3 plugin. And so in our unit test, we were ending up loading Moose a lot more than we needed to, and we were able to speed up our unit test because we switched this plugin from having to use all the time to just only loading net Amazon S3, this heavy Moose-based module when we needed it. But we could have alternately solved that with a different design pattern and say, look, if you're loading this all the time and you're not actually using it, maybe you should re-engineer things so you're only loading it when you needed it. But this technique is called lazy loading, the idea of instead of using something right up front, you just require it on demand when you need it. And that helped us in some case, and you might consider it. Just throwing it out there. Finding your slow test. First, we'll look at doing that with prove. If you're not familiar with prove state system, I recommend checking it out. It can save the state of your test suite in a file and then do things with it. So the first example I show is saving the state, and the next one here is it's rerunning the files that you just ran, but with the slowest test first. And that's one way you can sort of see what's slow in your suite. And if you look at the .prove file it contains, it has that raw timing data in there. This isn't my preferred way to find slow tests, but a lot of people already have prove installed, and it's easy to, yes?
In the test harness distribution, there's an examples directory with the file called analyze_test.pl, which will analyze this for you and dump out that information.
What was the module name?
In test harness?
Test harness.
In the distribution, in the examples directory, it's called analyze_test.pl. Okay. It will analyze that data for you and dump it out in the table.
It says test harness. In the examples directory, there's an analyze file that will analyze that and dump out test data. So that was very helpful. We use Jenkins, which has also been mentioned here. It's a continuous integration server, and it can also help you find your slow test. We get our test tap output converted to the JUnit output, and this is a slide of example of that kind of output, and it has all these columns are sortable. And there's a duration column, so here we are sorted all of our tests by which one is slowest. And this is a great place to start to look to see, find your slowest tests and make those run faster. And this report helps you do that. It's again, I wouldn't necessarily install it just to find your slowest test, but if you're already using it, make sure you're looking for this information because it's there. It also graphs your test suite runtimes, and this is an example of that kind of graph. And it shows it both in graph form and then allows you to drill down to specific runs, how long each run took. And that could help you find if you made a particular improvement that got it down a lot, or if you made a mistake of some sort, something happened that started to go a lot worse, you could find it there. Let's see, other process speedups. You can organize your tests based on how fast or slow they run. This is basically using a directory name structure or a naming structure with prefixes or suffixes to help you identify all your tests and what kind of tests they are. And we already talked about standard naming conventions. You could also, say, use Jenkins or a tool like that to organize your tests into smaller suites. So you might run the unit test first because they are fastest, and then maybe if they fail, you don't run the rest, or you already get some feedback sooner because that's like a test suite and it's stopped and it's finished and it's giving you a result. So you could start fixing things even before the slower test run. And you could chain your tests together so you get some milestone reports before the report at the end, and that's another way you can get feedback faster. Don't run slow tests as frequently. I mentioned this option earlier. Maybe there's some options instead of running things every time you push, you could run some slow test overnight once, and maybe that's acceptable enough for your process. There's other ways. Just consider that idea of how you might find your slow test, and then maybe some of them can be run less frequently if they can't be just sort of inherently slow. And I just got ahead of myself. I mentioned the tip of using your continuous integration server to break up your test into smaller jobs. If you're using Jenkins, it has this post-build action, build other projects, and that allows you to say in Jenkins language, when this project is done, build this next project. And that allows you to get these intermediate reports before the end. Remember that tests are code? This is something I get myself in a different mental state, like, oh, I'm it's test. I have to think about it differently, as different solutions. But all the things you would do to make code faster, you can make tests faster. And I forget that sometimes, so I thought it was worth mentioning. If you're using a database and the database is persistent, you can make sure the database is well maintained, taken care of, and just use all the other tools you would use to improve your code speed. Encapsulate repeated code and make it faster. Yeah, don't do more than you need to. I talked about that with the login function, using smaller data sets. That's all. Other questions?
This is slightly off topic, but I suspect you may have encountered it since you did mention that you knew when you remodified certain tests, they were running with no loss of coverage. Have you discovered any insights in how to use developed coverage in large test suite that affected how you overall structured your test suites?
No, I have not used develop cover. I just was using like logic. Like I knew I didn't log. I knew I didn't need to do the login sequence 100 times. Stuff.
Can I comment on that?
Yes.
What I do with stuff like that is there's a problem with unit tests. You can unit test stuff and get like 95% test coverage, but it turns out a lot of the code you're covering is dead code, or it could be dead code. So if you have, say, some of your tests in an API directory, everything that's publicly accessible for an API, all of our code should be accessible through the API. So if you just run develop cover against that, you don't have an accidental case where you're generating fake code coverage for code which will never execute. So that's part of how I like to structure my tests.
Right. Yeah. With my Selenium and Mechanize test, I would not duplicate there, but I do like having unit tests, and I don't mind if my functional test and my unit test duplicate some.
What Jenkins plugin we're using for tap? I use one, but it doesn't look like it gives me as good output.
I don't think I'm doing the inverse. Instead of using a tap plugin, I'm generating JUnit and sending it JUnit. And it's not beautiful and perfect either, but there's a couple tap to JUnit converters that are out there in the white shirt.
On the subject of masking the database tables, do you find that works, I guess, better, faster, maybe cleanup versus doing transactions or locking, so that basically, I imagine if you have tests that are doing similar operations or touching tables, is it faster to do the mask? Because you potentially have to mask a lot of tables versus just simply doing a transaction and boarding it or something like that.
Yeah, I have not done much with the transaction and rollback, but I have learned that deletes are slow. And one thing we do that I didn't get into here is to make our tests faster, we actually don't delete our test right away. We use a Jenkins job called delete test data that runs later. And so inserts are fast. So when we would insert something, instead we insert a row into a table which says, clean up this ID in this table later. And that's, again, gets me my results faster. And then the cleanup job runs later and it does the slow deletion later. I think you run into the same problem with transactions. That's kind of what would be happening in the rollback phase. But try it. Right here.
One thing we've done is a lot of our unit tests call other modules in our code base. We've tried to use develop cover to analyze overall as a set of unit tests what's covered and what's not. And we found that it was literally so slow that it is just not usable. It would not be, it would take, whereas our overnight test suite might take 45 minutes or an hour, it would take 6 or 7 hours to run. So develop cover is great if you're working with a small set of modules, but it's awful for performance if you're working with a large set of modules.
Yeah.
It's just not functional.
Yeah, he's saying that develop cover is slow, and we've had the same experience and run it infrequently for the same reason. In the back.
I use develop cover as a second step in my pipeline, and it only runs if the unit test pass. Another thing that I think is helpful if the code I'm testing is using Divic is to create a specific SQLite database that avoids all those socket connections and network interactions of clicking the code database. And I lost minutes on the test once that went.
So you're saying you use SQLite instead of, say, Postgres or MySQL to speed things up?
In this case, I think it was Oracle.
Oracle, okay. Green shirt.
Bang for the buck, if you were ordering, the things that you've done, where do you see the biggest increase going from the top down?
Parallel, #1. It's huge. That was the biggest thing. And yeah. I think we actually, because we have a persistent database, it had also just gotten slow, and we cleaned it up, and that made a big difference. But also, something like the login thing, which we're doing all the time, anything you're doing, if you've have a systematic problem. Otherwise, I'd head to the list of the slowest tests. It's probably a lot of your slowness is like 80-20 rule. It's probably just a few tests that are really contributing a lot.
Can Jenkins do parallel tests?
Yes, it has what it calls build slaves, which can be on the same server or on remote servers. And you can also give it a maximum number of build slaves that it can do. And yeah.
You said you weren't using the pre-fork testing, the ModPerl.
The fork proof, right.
What couldn't you use that, or what problems do you hit?
Yeah, I was, I'm not certain, but I was discussing it on Stack Overflow. The question title was like, how to run some tests in parallel but not others. I think it wasn't producing the right result at the end. Like, it just got to the end of the tap and stopped and didn't produce a summary. And I learned from dealing with that rule system that it hadn't been documented, so it was not well used. People didn't know it existed. So there wasn't really a lot of wisdom that I could find about how to deal with it. But it might be fixable, so.
You can contact Nick Clark. He was using that for parallelizing the test of the Perl core.
Yeah, I did find the Perl core was using it, but it might have been it was a particular combination of, I wanted to say run all these in parallel except these 10 things at the end run in serial. And if you run the rules in a different way, they work, but not in the way I needed them to.
When you clone Mechanize or even Selenium like that, how do you deal with situations where you have like either variables that are part of the state of the application but they're on the browser side, or maybe even like you don't want certain transactions to occur more than once, like maybe it's a credit card form or something that's sensitive, that changes the state of the system. So if you clone it and use that same thing 3 or 4 times, the first time you use it, you expire it effectively.
Yeah, it wouldn't solve all those kinds of problems. He was asking about the cloning trick with Mechanize and how it would work if the application state is changing too. It's just some cases it wouldn't work. It only can work if you want to go back to a state that you already have, and so you might need to use some other trick there, just deal with that one being slow. Thank you all for coming. And if you need any help moving your couches, I'm available.